Welcome back, everybody. Today we're going to be looking at creating a wall run and wall jump mechanic inside of our game. There are a lot of ways to do this using C++, and there's a new system called Mover that would allow for some dynamic movement controls, and this is going to focus exclusively on blueprints and the character movement component. So with that said, let's get into it. First thing we're going to want to do is establish the intention of our actions. So I'm just going to set up two comments here, right? One comment is going to be for our wall jump area, and one comment is going to be for our wall run. And we're going to give ourselves a little bit of space to work with on these because it will take up some room. And obviously you can collapse these to functions at a later time, but right now we just want to see everything all at once. So for the wall run, we want to check to see if there's a wall first, and then we're going to fire the character off in a direction to launch them at the wall so they can stick to it while they're moving. So for this, I know that I'm going to end with a launch character, and along the way I need to check for a wall. So we're going to use a line trace, and we're going to choose line trace for objects. To make sure we're checking for the right type of objects, I'm going to promote this object types pin to a variable, and we're going to call this wall run types. And when I compile this, it'll throw a warning saying that I don't have any types set. So all I have to do is select the variable. We're going to add world static and world dynamic. If there's certain things you only want to be able to wall run against, then you can create a new object channel, and then you can check for those things, and then the player will only be able to wall run against those objects. Using the world static and world dynamic, it's a little bit more robust of a system, but it also has some design considerations in terms of making sure you don't build a level the player can get out of. So with this set up, what we want to do is figure out where our line trace is going to go. We're going to fire this from our strafing, which is going left and right. So anytime we're going to strafe, we want to do a line trace to check for a wall. So what we're going to do is we're going to get the actor location as our starting point. So from the center of the actor. And then we're going to make a modification to that to get our ending point. So for the ending point, what we want to do is get the actor right vector. And this is going to be going to the side of the player. And then we want to multiply that by the input value for our strafing. So if they're strafing to the right, it'll be positive. If they're strafing to the left, it'll be negative. This will allow us to flip our vector in the direction that we're looking for. We're getting plus or minus 1, or times 1 or negative 1. And then we're also going to scale this by a float. We'll turn this into a variable. We'll call this wall run. Validation range should be good. And so this is going to tell us how far out we want the character to look for walls. I'm going to compile this, and we're just going to throw this to a simple 100 to start. And then this is going to pipe into our endpoint for our line trace. And just to make sure that we are doing things right, I'm going to put this debug to persistent to make sure that things are at least showing up correctly. So if I go left or right, it should be drawing them by left, right, right, left, right, left. You can see I'm alternating. It's going to the side that I'm moving to. And if I go over against a wall and I switch over to wireframe mode, you can see the greens are validating. I am getting active hits on dynamic objects. I think this is DSP over here. That's registering as well. Perfect. So things are going well. I can turn off my debug since I know I'm firing correctly. What I want to do then is break my hit result so I can get all the details that I need to calculate this. I'm going to check to make sure if I have a blocking hit. If I don't have a blocking hit, I don't really need to do any of these additional calculations, so we don't want to burn up processing time. And I want to grab specifically the normal here. The normal is going to look at where the hit was in the world. It's going to find the polygon of the collision of the thing that it hit, and it's going to fire straight off of that surface. So straight from that surface is going to get us away from the object. So what we're going to do is we're going to take that and we're going to negate that vector. When we negate that vector, that's going to give us the opposite. It's the same thing as multiplying it by -1. It's just wrapped up into one node. We're going to take that negative vector, which is still a unit vector. It's still a length of 1, and we are going to add to that the up vector. So you can add up vector, or you can just do the add here. And then we're going to normalize that, because if you know your basic geometry in trig, you'll know that the one length on the normal and the one length on the surface, or the up vector, are going to result in, probably if the wall is vertical and a square root of 2 hypotenuse, which is not going to be uniform for us to scale from, so we're going to normalize that down to 1. So we're going to take this and we're going to multiply that by another float. And we're going to promote this to a variable, and we're going to call this wall run strength. So our wall run strength is going to scale the vector that we're going to be launching the character in. And of course, if you want the character to have a more intense climb or be focused more on forward movement versus vertical movement, you can always scale these by coefficients, and that'd be just fine. For the wall run strength, we want to compile that so we can get a variable in here. Find that 8 or 9 is roughly the same as no effect here. I'm just going to use 12. It's a mild effect. If you wanted, I think anything up to 22 would be fine. If you start going above that, then you start pushing the character up the wall. It's more of a climb than a run. So if this is true, we'll launch the character. There's going to need to be some error handling that's going to come in here. And actually, just to make this a little bit more pronounced, we'll do 15. All right, so if I want, I can jump and you can see where the character is falling down. Landed just about here. So about 300, 400 away from the end. And then if I wall run, you can see I was able to go much further than the end because of the force pushing me up and into the wall. So with that in mind, I think that our launch is working, but we have some issues. If I get down to the ground here and I start going to the wall, you can see I get this jitter. And also if I jump up into the wall, I get a little bit of climb. And you may not want the player to be able to climb up the wall. If you wanted to have like a wall run, you'd probably get a different tracking for the player for like when they're running at the wall. But we want to limit this a little bit, at least in the way that we're implementing it. So we're going to be using something called a notify, apex notify. So for us to use the apex notify, we have to understand that that is a attribute that is built into the character movement. If I come over here and we look at apex, so here, notify apex. This is a variable that basically says it will tell us when we hit the peak of our jump, right? And so the notify apex is by default set to false because it doesn't want to always go and check for that. So we need to manually set this to true. And then there's a specific function that we'll need to attach to get that to reset. So if we have our character set up here for wall running, this is the general layout. We're going to intercept that we only want to look for wall runs after we've hit that apex. So basically once we've hit the peak of our jump, then we can start to do our wall run. This will also keep us from running into the issue of when the player is low to the ground, if they're jumping right up into it, they get that like little stagger that maybe prevent them from having the full height of their jump. So to avoid that, we're going to in our wall run, we're going to grab our character movement component down here, and we're going to get notify apex, and we're just going to branch off of that. So for the notify apex, when it's set to true, that means it's checking, and as soon as it hits the apex, then it sets to false. So once we've hit the apex, then we're going to start to look for these line trays for objects. So with those all set, this will give us a clear cut on when we're going to be checking for us, but we also need to make sure that we're resetting that value appropriately. So we're going to need to do two things. One, in our begin play, we're going to want to initialize that. So if I do set apex, we're going to set that to true by default here. And there's a couple different ways to approach this depending on how you're doing error handling. But we want to do that. And then we're also going to reach into a function that we have called on movement changed. If I could type, there's an E in there. And so on movement changed is part of the character movement system. And this is going to basically fire this event. Whenever the thing changes, it'll tell us what it changed to or from. And we're going to go from the new movement mode. We're going to take a switch on that. So a switch on any enum is going to give us the list of objects or options that we have, and we can fire off different event execution lines based off of which one it is. So whenever we're set to walking, we're going to basically repeat this function over here. So I'll just copy these down here. So whenever we are walking, we're going to set that to notify. Typically for Apex Notify, the implementation suggested that you turn on the check when you're launching. So once you're set to the falling action. But in this case, we're trying to handle the bump on the wall. And so if I get down here and I have the wall, you'll notice that I'm not getting my bump anymore as I'm driving into the wall. So that's solving that problem. Puts us in a pretty good situation for the wall run. I don't know if there's much that we have to do with this yet until we start to implement our wall jump. So with the wall run in place, that's handy if all you want to do is have the player run across certain things and then fall down. But typically with the wall run, you want to add a little bit more acrobatic elements where you would expect the player to be able to jump off of it, or maybe you're just going to rely on some other mobility options like adding grappling hooks or things like that. But let's say you do want to have the jump. So if you want to have the jump, then there's a few things that we want to consider. That we already have a jump behavior and we don't want to ruin that jump behavior. So we're going to actually be checking at where we can modify jump to allow it to exist perfectly fine on its own and then also facilitate our wall jump behavior. So we're going to go once again to our character movement, and from here we're going to get movement mode. So if I have get movement mode from here, then I can use my switch for the movement mode. And so anytime the player presses jump, if they're walking, then they'll jump. And then if they're falling, then we're going to do a check. So if they're falling, we want to check to see basically, are they allowed to wall jump? We need to control that for ourselves. If you had custom movement modes with C++, a little bit easier to define custom states. But here we're going to see if they can wall jump, then we're going to go fire our wall jump behavior. So our wall jump is going to run over here. So this will be the true thing that we do. Inside of our wall run, real quick, just to make sure that we're allowing this only at the right times, we want to run off of our blocking hit. For true, we want to set a variable. So I'm going to create the variable here and wall jump. And we're going to attach that one to the true and one to the false. So if it is a blocking hit, then they can wall jump. We know that's only going to be available after they've reached the apex, right? And so if they're not aiming at this anymore, then they cannot wall jump. Probably a few other error or edge handling that elements that need to go in there. For example, if they land on the ground, we probably want to turn off can wall jump, things like that. So just be mindful what you have going on in your own system to make sure that you're accounting for all those edge cases. So with that in place, we'll go look over at wall jump. For the wall jump, we're going to need to get the normal from the wall that we're referencing. So this variable right here is going to need to become a variable, and we're going to call that wall jump normal. And we're just going to throw that in, I think, here with the wall jump. This will make sense. If I can wall jump, then I have this variable. And if I can't, then I don't need to worry about assigning it. So this hasn't interrupted my mechanics at all. This is just saying when it's true, instead of jumping straight to launch, we're setting up some controls for the wall jump. And then in the wall jump, I can grab that wall normal, and we're going to get the angle that we're going to launch the character at. So we're going to take this angle, and we're going to get we're going to mix this with, say, get forward, actor forward vector. There we go. We're going to get the actor forward vector. So we're going to mix the direction that's perpendicular to the wall and the direction the player is looking. So there's some variability based off of the skill usage of the ability. And then we're also going to combine that with an up vector. It might be prudent to normalize these and then add it in and normalize that again. But for expediency, we're just going to normalize this all together. And then we're going to take this value and we're going to multiply. We're going to change this to a float. And then from that float, we're just going to give ourselves a wall jump strength. And for the wall jump strength, we need to compile, get ourselves a value. I'm going to use 680. I think the default jump is something like 400. I do jump velocity 420. So in contrast to that, the wall jump strength is going to be a little bit higher. So while in the air, you'll be a little bit more acrobatic. And then with that value, we're just going to say launch character. And this is going to come off of our true over here. And again, this could all probably be collapsed down to a function. And we are going to override the X, Y, and the Z for this jump to make sure the character isn't being catapulted. We could not override the X, Y, and that would allow you to kind of accelerate as you were wall jumping, but maintaining a level of verticality that was consistent. And then for this, once you jump, your ability to jump is affecting your apex notify. So if I don't reset this, if it's always false, then I'll be able to jump perpetually. So I also want to, in this moment, go and reset our apex notify right here. And again, all these places where I have reset notify apex to true here, here, and here, that should probably become a function. That way we can edit it in one spot and add functionality and conveyance as needed. So with this in place, I think if we've done things correctly, we should be able to wall bounce as we head down this corridor. And of course, level design not forgiving. Be able to jump our way over to the final destination here and make our way around. And that's a brief look at how to set up wall jumping and wall running. So if this is something that you think you could use in your game, I hope this helps get you started. There's definitely a lot of curation that goes into this, making sure the values are set correctly and that the behavior matches the design of the level that you want. But I hope that this at least gives you the baseline to be able to modify it to make your own, to go out there and keep building.